So very good morning, my dear friends. Yesterday we have started the deflections and you have seen all the introduction double integration method you have studied. The drawback of the double integration method is if the point of zero slope is unknown. If the point of zero slope is unknown, this method is not valid. So whenever you want to use the double integration method, we should know the point of zero slope is required. Hence, this method is suitable for all cantilever beams, because in all cantilever beams, you know the zero slope will be at the fixed end. And simply supported beam under symmetric loading. Simply supported beam, symmetric loading, we know the location of zero slope. But when the location of zero slope is unknown, that is simply supported beam unsymmetric loading. In that case, double integration method is not valid, where you should go for the Macaulay's method is required. But this method is a modified double integration method. Equation is same, only the integration rules are changed now. Now, yesterday at the end of the lecture, you have studied. Conclusions are slope is proportional to, in place of concentrated moments, slope is proportional to L. Under concentrated point load, slope is proportional to L square. Under distributed load is proportional to L cube. Under distributed load proportional to L cube. Then deflection will be one order higher than slope now. Hence, under concentrated moments, the slope is proportional, deflection is proportional to L square. Under concentrated point load is proportional to L cube. Under distributed load is proportional to L to the power of 4. And under concentrated moments, the stiffness, flexural stiffness is going to be C1 into EI by L. Just like axial stiffness AE by L, torsional stiffness GJ by L, but here EI by L, but constant C1 will be there now. But under concentrated point load, the flexural stiffness is C2 into EI upon L cube. C2 into EI upon L cube. And out of these maximum slope and maximum deflection, if you know the anyone directly can calculate Y max by theta max is equal to C1 by C2 into L. C1 by C2 into L. What you are asking, Mr. Rajanshu? Sir, in chapter number 6, the value of C2, I think it is value of C1 from yesterday's lecture now. Where you are asking now? So now we are going to do that. I hope you are already thorough with all the standard formulas. Now directly we'll do the questions here now. If you remember all the C1 and C2, directly can do the question. And if anybody has not attended the generally second session now, the Hyderabad Medici team is going to upload immediately after the end of the class. Immediately, once lecture is completed, they are uploading. But it will take some time. Once the Medici here, within 15 minutes, the upload is going to be they are going to do it. But for that one, finally, Delhi team has to do it. And mapping, etc., it will take at least 6 to 8 hours to be uploaded if you want to see it now. Immediately, we cannot see that lecture now. Some process is going to be there now. They have to upload it, then mapping has to be done it. It will take some time now. At least 6 to 8 hours of time is going to be required now. So don't send that messages. And yesterday one of your friend night 10:30, sir says still the lecture is not uploaded. That is not in my control. If you have any queries, subject queries, technical queries, please send it to me. The non-technical queries, I am not the right person. If you have any queries regarding the non-technical, like your upload is not done it, everything, you should contact the Medici team now. But you should have some patience. Medici also going to do it immediately, but will take some time, will be there now. 6 to 8 hours of time is going to be there. When the lecture is completed 6 o'clock, you can see the lecture around after 11 o'clock or 12 o'clock, you can see that lecture now. Let me go through the table because one of your friend is mentioning. Correct only they have given out. You check your side now. Everything is correct in the tabular form. So write in the first question. While you are solving the problem, mostly you are going to come across these cases now. The cases which you are going to come across, I am going to put it here now. One is a cantilever beam under pure bending. Probably this is the first case. C1, C2. C1 is 1, C2 is 2. I'm not writing the entire now, whatever required for the question, that only I'm writing now. Next, cantilever beam under point load at the free end, 2 and 3. Then simply support beam subjected to point load. (16 and 48). Next, cantilever beam under UDL. So these are going to be required while solving the problem. Here constants are 6 and 8. Simply support a beam UDL. Cantilever beam under UVL having an intensity at the fixed end. Here and 24 and 30 will be there now. So these are the cases you are going to get it. While solving the problem, these are the cases are required now. Fixed beams are not in the syllabus, but I have given they are required. Some of the engineering service as well as what the state service exam, they are asking the questions of fixed beam. And that is also required when you are doing the problems on the theory of machines transverse vibration. But these are all valid when EA is constant. Your tabular form is the first one, is the third one, and fourth one, and fifth, and maybe in between can one more be there. This may be sixth, and the seventh is going to be there now in the tabular form now. If you know the C1 and C2, then you can directly do the questions now. First question you are going to take it. But somebody will ask now, sir, in the design of the shaft, which one I have to use it now? The equations also valid for the shafts now. But they are all given for the beam. But which equation I have to use it for the shafts now? You have to correlate the shaft with one of the beam. You have to correlate the shaft with one of the beam. Beams are supported by rigid support, shafts are supported by bearing. Now which equation I have to use it for the shaft design now, as well as the transverse vibration? You are correlating the bearing with, you have to correlate the bearing. You have to correlate the bearing with one of the support. There are three bearings are there now. Short bearing, square bearing, long bearing. That you are going to study the machine design bearing chapter. Short bearing means L by D ratio, length to diameter ratio less than 1. If L by D ratio is 1, is a square bearing. If L by D ratio greater than 1, is a long bearing. Short and square bearing behave like a simple support. Short and square bearing behave like a simple support. Short and square bearing behave like a simple support. Long bearing behave like a fixed support. Long bearing behave like a fixed support. So the question will be, determine the natural frequency of a shaft. Determine the natural frequency of a shaft when it is supported one end by long bearing and other end a flywheel is mounted with a weight of W. A flywheel with a weight of W is mounted. Then it comes under which case now? One end is a long bearing, means it is a fixed support and weight of the pulley is acting downward. So that case will come under which this case now? Next. A shaft is supported the both ends. Supported the both end by two bearings. And find out the natural frequency of the shaft due to self-weight. If type of bearings is not given, you have to assume a short and square bearing. If type of bearings are not given, you have to assume a short and square bearing. Means it will become as a simple supports now. Due to its self-weight, means it will comes under what? A self-weight of horizontal member, the UDL. So that will comes under, determine the natural frequency of a shaft due to its self-weight when it is supported at the two end by two bearings. Default the bearing should be assumed as short and square bearing. Short and square bearing will behave like a simple support, and the horizontal member shafts are default the horizontal. Horizontal member weight will act as a UDL. So this will come to in this case now. Next, shaft is supported the one end by long bearing, one end the short bearing. One end by long bearing, other end by short bearing. Then a flywheel is mounted with a weight of W, or a gear is mounted with a weight of W. That will come under one end the long bearing, other end a short bearing in a proper cantilever beam. Proper cantilever beam. Proper cantilever beam subjected to point load. So this is going to be required when you are going for the vibrations as well as the design of the shaft. So if somebody will ask now, which equations you are using for the design of the shaft, mean what the answer now? Sir, we have to correlate the given shaft with one of the beam. How do you correlate it now? Correlating the bearing with one of the support. Short and square bearing will be correlated with, short and square bearing will be correlated as a simple support. Long bearing will be correlated as a fixed support. But when type of bearing is not given, default you have to go for a short and square bearings. Short and square bearings behave like a simple supports. Long bearing behave like a fixed support. So here L by D ratio less than 1. L by D ratio, L is the length and D the diameter of the bearing, equal to 1. Here L by D ratio is greater than 1. Sometime a question will be what now? A shaft is supported the 2 by 2 long bearings. Find out its natural frequency. Find out its natural frequency due to self-weight. Means nothing but what now? A fixed beam under UDL. That's why I given that fixed beam UDL also given. For fixed beam UDL, what the constant now? 384. Fixed beam UDL is a 384. Then a shaft is supported the 2 by 2 long bearing. A flywheel is mounted with a weight of W exactly the mid span. Nothing but about a fixed beam subjected to constant point load at mid span. Then the constant will be, what the constant now? 192. 192. In place of this fixed support, here I am going to provide fixed support mean long bearing. So it will become as a fixed beam subjected to constant point load. So then this constant is 192. So what the conclusion of for same length, same flexural rigidity, same length, same flexural rigidity and same loading condition. Identical beam. Identical beam means length is same, EI is same and same loading conditions. In that case, the simply supported beam deflections are less than the cantilever beam. Same thing, fixed beam deflections are going to be, fixed beam deflections are less than the simply supported beam. So always the fixed beam will give the less slope and less deflection when compared to simply supported beam for the same condition, same loading condition, same length and same EI. And simply supported beam will give the less slope and less deflection when compared to cantilever beam. Now same thing with the cantilever pure bending. Case 2 we check it now. Simply supported beam pure bending. Simply supported beam pure bending the case 2. What this constant you got it now? 8 you got it now. 8 means how much percentage is less now? 75% is less. When a cantilever beam pure bending deflection is 10 mm. But same beam, same means what? The same identical simply support beam. Identical simply support beam under same condition. The deflection will be 2.5 mm. Mean 1/4 will be there now. 1/4 means how much percentage reduction is there now? 75% reduction is there. Now, if I am going to replace this by fixed support, here this is what the 192 means. Once again, deflection is decreases by 75%. Here constant is what a 192 means. Here if I am getting a deflection at C is 10 mm, If I am going to replace by fixed support, the deflection will be 2.5 mm. So for the same identical condition, fixed beam, slope and deflections are less in comparison to simply supported beam, and simply supported beam, slope and deflection are less than cantilever beam. So supports are going to make a lot of difference now. Length is same, EA is same, loading is same. Now write in the first question now. Determine theta b and yb. Determine theta b and yb. This is about a cantilever beam. Which one is attached? Now bracket is attached, and load is applied at the end of the bracket. Load is applied in vertical direction. It is equal to how many loads now? This will be equal to one constant point load and one couple. So this will be equivalent to this cantilever beam is, this can be considered about a cantilever beam subjected to a constant point load and a couple. All this you have studied in SFD, BMD. So you can use your superposition principle. Strain-energy we cannot use the superposition principle, but stress, strain, deformation, deflection directly can use the superposition. Deflection is proportional to deflection, a function of linear function of the load. Deflection is WL³ by 3I. So deflection is proportional to W, linear function. Slope is also about a linear function of the load. So always we can use the superposition principle for the parameter which are linear function of the load. So directly what you can do it now is a combination of which case? Now this is a combination of these two cases now. Combination of these two cases, that's all. First you assume the constant point load alone. When constant point load alone, what the deflection now? WL³ by 3EI. Next, couple is alone. So what the deflection now? ML² by 2EI. But both should be added or not now? Whenever more than one load is acting, see the direction of the elastic curve. This is also giving a bendment is clockwise. It is also giving a bendment is clockwise. When both the bendment are same direction means both the elastic curves are downward. Both the elastic curves are downward. When the elastic curves are in the same direction, then at that time simply addition is going to be there now. By chance this load is the upward. This load is the upward. It will give a bendment in which direction? Anti-clockwise. So due to W, the beam will be rotated in anti-clockwise. Then elastic curve is a upward. When M is acting alone, is a clockwise, then the beam is going to be rotated in the clockwise. So whenever more than one load is acting, you can use the superposition principle. But when the sign conventions are compulsory, when both the elastic curves are in the same direction, sign convention optional, simply can add it now. But when both the elastic curves are opposite direction, one is a downward, one is a upward, in that case sign convention compulsory. But in this case, both are what now? Bending in same direction. Both the elastic curves are same direction, downward. Simply can add it now. So what the deflection due to this? Now WL cube by 3 EI. And what the deflection due to this? Now ML square by 2 EI. Directly can add it now. Superposition. We are assuming the W alone, next M alone. This question given directly in the workbook. This is one of the gate paper question. So these questions can be completed only if a student is what now? Remember the constant. Otherwise, use any method. It will take the some time now. So these are all given as 1 mark and 2 marks question. So if you can remember this constant, only can do it now. This is what now? First case. Sorry, this is the second case and the first case. So directly what the here C1 and C2 are what are 2 and 3. What the C1 and C2 now? 1 and 2. So your deflection is WL cube by 3i, slope is WL square by 2ei, your slope is ML by EI, and deflection is ML square by 2ei. But you have to, both should be added or what? Both the values should be added or not now. Then you have to check it. This is also giving a bendment is clockwise. It is also clockwise. Mean both the elastic curves are in the same direction. Simply addition you can do it now. By chance upward, this will rotate in anti-clockwise. Then you have to go for the sign conventions are compulsory. So sign convention is compulsory when both the elastic curves are in opposite direction. When both the elastic curves are same direction, sign convention optional. Simply you can do the addition. Only for this case, what the shape of the elastic curve here? Na parabola. This you have studied now. This I am calling as y1. Y1. And how to get a slope now? You have to draw a tangent. Only for this case I am doing now. Remaining directly I am going to write down now. So theta should be measured in which direction now? In which direction? Less than 90. Clockwise direction I am getting less than 90. So what the theta 1 here now? WL square C1. What the C1 value now? 2 EI. What the direction now? Clockwise. And what the Y1? 1 order higher. WL cube C2. It is a downward. Next here, what the shape now? Circular arc. It is a circular arc. Because already know the equation shapes will not make a difference now. It is a circular arc, parabola, we cannot make a difference. Because already know the equation. But when you are deriving the equation, these shapes are going to be required now. Here, this is what now? It's a circular arc. If you can complete it, what now? It's a quarter circle now. If you can complete similar, what you are going to get a complete circle, you are going to get it now. Somewhere you are going to get the center of the circle. Everywhere the radius of curvature is same. This is the center of the circle. Everywhere the what radius is same. Now here y2 downward. So y1 is also downward, y2 is also downward. Directly can add it now. And here, how to get a slope once again now? Once again clockwise direction. Clockwise direction. Now, what the theta to here now? ML C1. What the C1 value now? 1. EI. Clockwise. What the Y2? ML square by C2. What the C2 value now? 2. But what the M value is given now? WL by 4. So it will be WL square by 4 EI. What the Y2? WL cube by in the question they are going to give either slope or deflection. Any one question is given an objective now. But in all the questions I am doing the both now. Now directly can add it now. How we are getting this condition? Superposition. But both are in the same direction. Simply addition. Addition. So what the theta B? Theta B is equal to theta 1 plus theta 2. This is only for proper understanding. But those who are thorough directly can add it now without drawing this figure. WL square by 2A, ML by EA. Directly can add it. Both are in the same direction. So only for this question I have drawn it. The remaining question I am not drawing these figures now. So what the theta 1? WL square by 2A, and this is what WL square by 4 EI. So it will be 3 WL square upon 4 EI. So it is a clockwise. It is also clockwise. It is also clockwise. Y1 plus Y2. WL cube by 3 WL cube by 8 1 by 3 plus 1 by 8. I hope it should be 11 by 24. Check it now. So all the questions are like this only. But if a student is unable to recollect the standard formulas, but how to remember the standard formulas? Yesterday I given only you have to remember. I had the C1 and C2. Numerator corresponding load, denominator EI. Under concentrated moment, slope is proportional to L. Then automatical deflection proportional to L square. Constant point load, deflection is slope is proportional to L square, and deflection is proportional to L cube. UDL and UVL. Slope is proportional to L cube, deflection is proportional to L to the power of 4. So if you remember the C1 and C2, directly can get it now. Otherwise use any method now. It will take the more time now. That only mentioned this chapter is about now. Even for gate examination test for memory power now. I'm modifying this question. Determine the value of x. Determine the value of x. First condition is slope at b is 0. Deflection, second condition, deflection at b 0. Two separate conditions now. Determine value of x. If first condition is slope is 0. Deflection is 0. Now what change you are getting now? W is downward, but this is give a couple in which direction? Anti-clockwise. Couple will be anti-clockwise. Means one elastic curve downward, one elastic curve upward. Therefore, in this case, sign conventions are compulsory now. So this diagram will remain same, but here this will change now. This is giving a bend in clockwise, this is anti-clockwise. Both the elastic curves are opposite direction. Now is a circular arc. Is a circular arc. Y2. And how to get the slope now? Draw a tangent. So in which direction I have to measure it now? Less than 90. This is less than 90. Anti-clockwise less than 90, clockwise more than 90. So here you have to measure in anti-clockwise direction. Now it should be so for the m value now wx as per our notation, this is about of negative, this is a positive, anti-clockwise positive, clockwise negative. So for the first condition given, theta b should be 0. That is theta 1 plus theta 2 should be 0. Theta 1 is what? A negative. Is the first condition, but the theta 2 is positive. So from this one, x value will be x value is L by 2. X value is L by 2. That is, if the slope should become 0 here now, the length of this member should be L by 2. Next. Downward deflection is negative. Upward deflection is positive. X should be 2L by 3. X should be 2L by 3. For civil engineering students, this is a very, very important chapter in civil engineering. Completely structure analysis, what this is going to be very useful. But mechanical paper questions are going to be less and the simple questions are going to be there. If a student is attended these classes from civil teacher, and if they are attended my class now, then definitely what are they do? Sir, my teacher has done very complicated questions. You have done all the simple questions. I am teaching what as per the mechanical. I am not teaching for civil engineering point of view. Some institute, civil and mechanical students are combined. Civil and mechanical students are combined. Then the teacher is going to teach with respect to civil engineering point of view. Before doing all this thing now, after completion of the class and subject now, do the questions of the previous paper. Previous papers, not only one paper, last 20 years papers of 30 years you can take it now. 30 years of gate, mechanical, civil, not gate mechanical, gate mechanical, ESC mechanical, civil service mechanical. Then you check it now. If any of the question cannot be completed from the class notes, they can ask them. Wherever required, I spend the sufficient time now. Principal says sufficient time is going to be there now. That is very important now. SFD, BMD also spend it now. Where is required that I am going to spend it. Don't compare with one teacher with other now. Either civil teacher is going to teach with respect to civil orientation. What are the next question now? But if you ask the strain energy, you cannot do the superposition here now. Superposition cannot be done it because of what? The bendment is where is already done it now. Slope and deflection can be added. Superposition. But strain energies cannot be added because bendment is what? The varying. What the bendment here now? Wx plus more than one bendment is one is varying, one is constant. Then you have to go for the actual method. Integration is required now. Integration part is required. We cannot go for the superposition. Clearly I mentioned now. Next, I don't know. For the propped cantilever beam as shown in the figure. For the propped cantilever beam as shown in the figure. For the propped cantilever beam as shown in the figure. Determine support reactions. Determine support reactions. Comma. Maximum shear force. Maximum shear force, maximum bendiment, maximum shear force, maximum bendiment, and location of point of counterfacture. Location of point of counterfacture from fixed end. Location of point of counterfacture from fixed end. This question so many times repeated. The propped cantilever beam. Propped cantilever beam is always a statically indeterminate beam. So the reactions are determined with the help of the compatibility equation. That only explain now. So here to find out the reaction, we need a compatibility equation. Deflection equations are required now. So without knowing, this was question repeated so many times now. In the workbook also 4 or 5 questions are there. But a GATE exam 3 times is repeated now. But in the exam it asks only up to reactions. They ask only reaction. But I've asked find out the maximum shear force, maximum bendiment, and point of counterfacture. Everywhere here other than the EA is constant. What the total number of reaction? 5. Fixed support 3. hinge support 2, but non-zero reactions are 3. Non-zero reactions are 3. Here one vertical. Before going for the reaction, what should be a first step now? Find whenever a distributed load, what the first step now? You find out the total load. RB, RA, since horizontal reactions are 0, directly I am putting both RA and RB. Next, a moment reaction. Which beams are always statically indeterminate? Fixed beam, propped cantilever, continuous beam are always statically indeterminate. Now, what is the useful equation? Only two. Sigma V is equal to 0, sigma M is equal to 0. But equations are 2, unknowns are 3. Then we need a compatibility equation. That is, deflection at B should be 0. Deflection at B should be 0. If I use the sigma V is equal to 0, RA minus WL plus RB, 0. So from this one, RA plus RB. RA plus RB equal to WL. Next, what is the other equation now? Sigma M is equal to 0. So this is what anti-clockwise. Anti-clockwise I am negative. And what the moment due to total load. Next. So from this one, MA. Is the second equation. Two equations are there, but three unknowns are there. Three unknowns, but two equations, therefore statically indeterminate. Then use the compatibility equation. So deflection at B should be 0. Use the superposition. First you neglect this. Remove this support. Remove this support means remove this RB. Assume the RB is 0. Means I am assuming how many loads are acting on the beam now. One UDL is there, one consonant point load is there. One UDL is there, one consonant point load is there. First assume RB is 0. If I am going to remove this RB, that is what, if I remove this support, it will become as a what now? Cantilever beam under UDL. How many loads are acting on the cantilever beam now? One UDL and one consonant point load there. First assume RB is 0, means I am removing the support now. When RB is 0 means what? I am removing the support now. So it will become as a cantilever beam under UDL. Cantilever beam UDL, what the constant? 6 and 8. But I need the which constant? No, this one, no, deflection should be 0. Here slope is not 0. When the slope will be 0? Fixed support, but the simple support. So here slope is 0 or deflection is 0? Deflection is 0. So to find out the deflection, we need this now. So what the C2 when UDL acting alone? C2 is what the 8. What the deflection? W L to the power of 4 upon 8 EI. Next, assume UDL is 0. When UDL is 0, it is what now? When UDL is 0, means assume only RB alone. Means this will which case now? Case 2. So in that case, what the constant? 3. So due to UDL, what the deflection downward? W L to the power of 4 upon 8 EI. When RB is alone, it will become as a cantilever beam subject to point load upward. Deflection will be upward. W L cube upon 3 EI. So equate the both the deflection to 0. By using the compatibility equation. This is, first I am assuming the UDL alone. Next, RB alone. yb1 yb2. This is due to UDL, that is when UDL is acting alone. So deflection is downward. WL to the power of 4 upon 8 EI. C2 is what now? 8. WL to the power of 4 upon 8 EI. And this is due to RB. That is what a constant point load alone due to RB. Now you can substitute it now. YB minus WL to the power of 4 upon 8 EI. This is RB L cube upon 3 EI. So this is a compatibility equation. So from this one, RB will be I'm getting a positive. Positive means assumed direction is correct. Now if once you know RB, then you can find out RA from equation 1. From equation 1, RA will be 5WL upon 8. It is also positive, means assumed direction is correct. Always for reactions, you have to go for with the directions. Don't use the reaction cannot be kept in plus or minus now. You have to indicate the directions. Horizontal reaction means towards left or right. Vertical reaction upward or downward. Moment reaction means clockwise or anti-clockwise. You have to keep it now. Next, from 2. WL square by 8. Now this is, I'm getting a positive. Positive means the assumed direction is correct, anti-clockwise. This question cannot be done without knowing the standard equation. That's why these equations are compulsory. UDL alone, point load alone. Therefore, the combination of this will be what now? Fourth case. Just now what I have written a fourth case, and this will be what the second case. Whenever more than one load is acting, use the superposition. That is, assume the each load alone. Here both are parabolas only, both are parabolas only. Now once you know the reactions, then you can draw the SFD BMD. What is the reaction? You got it now. This is and this is WL square by 8. That all I mentioned. Once you know the reaction, for every beam, SFD BMD concept is same. So what is the shape of the SFD? Here how many constant point load? No, 2. One vertical line, one vertical line. What is the height of the vertical line? 5 WL by 8. 3 WL by 8. But here shear force positive, here shear force negative. And between two constant point load, whenever a UDL is there, inclined line. So what is the shape of the SFD? Two vertical lines, one inclined line will be there now. But here shear force positive, here shear force negative, means shear force changing sign. Changing sign. Then you have to find out the location of the where shear force changing sign. And what the shape of the BMD? Here bendment is negative. BMD consists of one vertical line. Here bendment is negative. Here bendment is 0. Bendment is 0. And between UDL, what you are going to get it now? Whenever a UDL bendment varies parabolically. In the question they didn't ask the SFD BMD. I taken this only, this SFD BMD I'm taking only to prove that my statement, once you know the reaction for every beam, SFD BMD of same principle. So whatever the conclusions, I made it valid for any beam, even fixed beam, continuous beam. But you have to find out the only reaction, beam to beam, only calculation of reactions or changes. But here to find out the reaction, what is required? A compatibility equation. Similarly, in fixed beam, compatibility equations are required now. Left hand side upward is a positive. Right hand side upward is a negative. And between two constant point load, whenever a UDL, shear force varies linear. Now once again, if I ask the maximum bendment, everybody is going to calculate at C. Incorrect. Sir, shear force is changing sign at only one cross section. Here bendment should become maximum, mean what the answer? No. There should not be any couple. So many times I mentioned, no, whenever the couples are there, whenever the bending couples are there, bendment need not be maximum at the cross section where shear force changing sign. Yesterday also you had done a question now. Most of the students maximum bendment means they will calculate it now. They will take this area. Sir, here bendment is 0. So MB minus MC. Sir, directly MC equal to this area. And directly they will take the MC, the M max. Is that incorrect now? We cannot directly tell it now. We have to calculate where shear force changing sign and where couples are there. Couples are there, what the A. So what the bendment here now? WL square by 8 minus. Next you have to find out the bendment at C. How to find out the bendment at C? MB minus MC equal to this area. So finally, whichever the larger, that is the maximum bendment now. Now how to find out this location of C? Equation required or not required? Not required. Shear force equation not required because of the linear variation. Clearly mentioned shear force equation required when shear force is varying parabolically, changing sign. Here directly can use the similar triangles. So if I use the similar triangles, WL by 8. So how to find out the bendment at C? This area, because MB minus MC. Here bendment is 0. Simple support bendment is 0. MB minus MC. So 0 minus MC. And this area is a negative. So what is this area of the triangle now? Half base into height. 9WL square by 128. 9WL square by 128. But what the bendment here now? WL square by 8. 9 by 128 is more or 1 by 8 is more? 1 by 8 is more. So maximum bendment will be at the fixed support now. Here bendment is 0. Here bendment is negative. How much is now? Here bendment is what now? This area MB minus MC. What this area? Triangle area. MB is 0 minus MC. But this area is also negative. Therefore MC you are going to get a positive. Mean point of contraflexure will get it. Now this is a hogging. Here you are going to get a sagging. So this value will be, check it by using the area 9WL square by 128. Then how to join it? Now when shear force is what? Decreasing. Therefore it should be parabola with a decreasing slope. And here to here shear force increases. Then it should be a parabola with a increasing slope. This is bendment at C, but it is not the maximum. Now this will be a point of contraflexure. Point of contraflexure. So this will become as the maximum bendment. Maximum bendment. Now to find out the location of point of contraflexure now. Here equation compulsory. Clearly yesterday mentioned now. Bendment equation is compulsory when bendment is changing sign under UDL, under distributed load. Always distributed load bendment varies parabolically. So whenever a bendment is whenever bendment is changing sign under distributed loads, whenever bendment is changing sign under distributed load, so always bendment equation compulsory now. Now take a section. Better to consider right side or left side now? Right side is better. Right side one UDL, one constant point load. Left side how many loads are there now? One UDL, one constant point load, one constant moment. So better to consider right side. So write down the bendment equation equal to 0, then we'll get the value of X now. What is the total load of this now? X by 2. So what is the bendment equation now? Minus WX square by 2. X is equal to 0. x is 3L by 4. So this is 3L by 4. But in the question it asks from fixed support. So from fixed support is L by 4. So what is the answer for this question now? Maximum bend moment is WL square by 8 hogging. Maximum shear force. WL by 8. And what the location of point of counterfacture? L by 4 from A. This was a gate mechanical question, but it asks only reactions. But similar question in the workbook, that is the gate civil engineering. Question number 11. Question number 11, chapter number 4. Question number 11, chapter number 4. So this was the question now. So here one concept is going to be required now. Similar question. Always is valid now. Difference of the bendment is equal to. Difference of the bendment equal to area of SFD is always valid now. Even couples also there it is valid now. But that is not valid under UDM is not valid, Mr. Abhiday Sharma now. That relation, how we got it now? MB minus MA equal to area of SFD, F equal to dm by dx. That equation valid under constant point load, constant moments. That equation not valid only under UDM. Under UDM. Please thorough with your conclusions now. Your friend is asking, sir, MB minus MC I used it, area of SFD, that is valid when there is no bending couple. Who mentioned like that now? Who mentioned like that now? That relation you got it, F equal to dm by dx. The F equal to dm by dx is what now? Is valid under constant point loads, constant moments, UDL and UVL. But that is not valid only under UDM. So MB minus MC is not equal to area of SFD only under UDM. Only under UDM. So the question was like this. This was a gate civil, this is a gate mechanical. The question was like this. Initially load intensity 10 is given now. Yesterday I done so many questions like this now. I asked when the load intensity is 100. What is the RA value? What is the RA value now? And flexural rigidity. EA is equal to 7,81,250 kilonewton meter square. This is the input data is given now. What is the difference between this question and this now? Is a proper cantilever beam. Is a rigid support, deflection is 0. Rigid support will not permit any deflection. Therefore, this is directly the proper cantilever beam and is a statically indeterminate. Is a statically indeterminate. Then how you calculate the reaction now? RB by using the deflection at B equal to 0. Deflection at B equal to 0. But slope is not 0 now. But this is what a which beam now? Is it a cantilever beam? It is not a proper cantilever beam. It is not a proper cantilever beam. Proper cantilever beam means what? There should be a rigid support should be placed now, but there is a gap is there. Between this beam and support, some gap is there. So the statically determinate or indeterminate? Maybe determinate, maybe indeterminate. Maybe determinate or maybe indeterminate. It is not a proper cantilever beam. But is it a determinate beam or indeterminate beam? We cannot tell it now. If the reaction provided by the platform is non-zero, if the reaction provided by the platform is non-zero, it is statically indeterminate. If this reaction is zero, the reaction provided by the platform is zero, it is a determinate beam. It will become as a cantilever beam. This will become as a cantilever beam only when the reaction provided by this platform is zero. But when this reaction will be zero, when this platform will offer a reaction, due to this the beam is deflected downward. So when the deflection is greater than 6 mm, it is not 6 meters. Suppose when deflection is what? More than 6 mm. When the deflection is more than 6 mm, then what happens now? The beam will push this platform downward. Then this platform will offer a reaction. But as long as the deflection is less than 6 mm, less than or equal to 6 mm, less than or equal to 6 mm, the reaction will be zero. Then it will become as a cantilever beam. So whenever a gap is given, is it determinate or indeterminate? Directly we cannot tell it now. Here, when deflection at B less than or equal to gap, that is 6 mm, then the platform reaction is what? A zero. Then this will become as about a which beam now? Cantilever beam. And cantilever beam is always a statically determinate beam. But when deflection is greater than gap, then the beam will push the support downward. Beam will push this is nothing but about a support. It will push the support in the downward. Then RB will be non-zero. RB is non-zero. When RB is non-zero, it is a statically indeterminate beam. It is not a proper cantilever beam. Assume by chance deflection is 10 mm. What about the 10 mm now? 6 mm is permitted, 4 mm is going to be restricted. 4 mm is what now? Sir, 6 mm is permitted and 4 mm is going to be restricted. But in the previous case, a completely what now? Is a proper cantilever beam always a statically indeterminate. So this type of questions, what you have to do it now? This type of questions, what you have to do it now? You make a one assumption. You have to make some assumption. Initially, I am assuming the RB is 0. Initially, I am assuming RB is 0. RB is 0 means, what the assumption I am making now? Deflection is less than or equal to gap. When RB is 0, this will become as a cantilever beam under UDL. Now you can find out the deflection of the cantilever beam at the free end under UDL. WL to the power of 4 by 8A. W is given, L is given, EA is given. If I am getting the deflection is less than 6 mm, your assumption is correct. Means it will become as RB 0. When RB 0, directly can find out RA. This is what this total load now. So once this RB is 0, directly RA equal to 500. First option is what? A 500 is given. That is correct now. But by chance, after calculation, I am getting deflection is more than 6 mm. Deflection I am getting, for example, assume the 10 mm. My assumption is incorrect now. Assumption is incorrect means RB is non-zero. Then what do you have to do it now? Put the RB is non-zero. Then at that time it is not about a cantilever beam now. Then use the superposition. What the superposition now? First assume the UDL alone, next RB alone. In the previous case deflection is 0, but here how much deflection is permitted now? In the previous case, how much deflection is permitted? 0. But the compatibility equation here, na? YB1 plus YB2 equal to 0. How much deflection permitted? 0. 0 is permitted. But in this case, how much is permitted now? 6 mm is permitted. Then what I have to do it now? Deflection downward due to UDL and deflection, upward deflection due to RB should be equated to deflection permitted. How much deflection is permitted? Now 6 mm is permitted. So whenever this type of questions are there, what should be the first step I have to do it now? The same concept everywhere is required. Even thermals is also going to be required now. First assume deflection is less than or equal to gap RB 0. So it will become as a cantilever beam. Cantilever beam. So initially I'm assuming the RB is going to be 0. RB 0. When RB 0 is a cantilever beam under UDL, now you can find out the deflection now. So deflection at B, WL to the power of 4 upon 8A. W is given how much? 100 kilonewton. Length is given. EA is given. Check it. You are going to get this value will be 10. The 10 means your assumption is incorrect. Assumption is incorrect. Means it is a statically indeterminate beam. By chance, if this load intensity 50 kilonewton meters is given, in place of W, if it is 50, then what about this deflection of 5 mm? Then assumption is correct. In the question, W is given how much? 100. W is given 100. I'm getting a deflection is 10. Therefore, the statically indeterminate. My assumption is incorrect now. So by chance, this load intensity 50. Then at that time, this deflection is 5. Means assumption is correct. Therefore, RB is 0. Then the beam is going to be what? A cantilever beam. Hence, that is, assumption is incorrect. Hence, assumption is incorrect. Hence, RB is non-zero. When RB is non-zero, it is a statically indeterminate beam. So, statically indeterminate beam. Then how many compatibility equation required? Then how to find out now? Deflection at B. Y1 plus Y2 should be 0 or non-zero. Here it is 0 because of deflection permitted is 0. But here how much deflection is permitted now? Out of that 10, how much is permitted? No, 6 is permitted. So always you have to equate it to the what? Permitted. That is gap. Why you are taking the minus? No, because downward deflection you are taking as a negative. This gap is what? A downward. Therefore, deflection permitted is downward or upward now? Deflection permitted is downward. Suppose somebody is going to take the plus. Somebody is going to take the plus. Then what he has to do it now? He has to take the downward deflection positive. Upward deflection is going to be negative. Why I taken this negative? Because we are taking the, as per our convention, downward is negative. Some textbook they are going to take the positive, means they are taking the downward is positive, upward is going to be negative. I have taken the negative because of what? How much deflection permitted? 6 mm is the downward deflection. That's why you are taken as a what now? Minus gap. So some textbook they are taken plus. You can take it now. If you take the plus, then downward deflection should be taken positive, upward deflection should be negative. So due to UDL, now use the superposition. First assume the now RB is non-zero. Draw this figure once again if you wanted it now. RB is non-zero. So due to UDL, superposition. What is the superposition now? First assume UDL alone. Next RB alone. So what is y1? Due to UDL. Due to UDL, beam is deflected downward. Then it is next RB alone upward. -6. If you take this a plus, then this should be plus and this should be negative. You have to take it. Now once again all the values are given now. Then you check it. RB will be, I'm getting a positive, means upward. Once you get the RB, then in the question is asking RA. So sum of the reaction should be equal to total load. Sum of the reactions equal to total load. Therefore RA will be 425. By using sigma V is equal to 0, RA plus RB equal to 500. So from this one RA will be 425. Suppose if you ask the moment reaction also, how to find out the moment reaction now? By using sigma m is equal to 0 minus MA 500 into 2.5 RB into 50. So MEA will be 1250. So check it, it will be 875. I'm getting a positive, means it is a anti-clockwise direction. So whenever these gap questions are given, you have to use this concept. First assume reaction is 0, means deflection is going to be less than or equal to 6 mm. But some students, what they done it now? First option is given 500. First option is given 500. Some students will ask now, sir, then what is the use of this data? There is no use of this data. Only to create a confusion is given. This data, there is no use of this data. Why they have given to create a confusion among the students? Some students will do it now. When load intensity is 10, RA is 50. When load intensity become 10 times, RA will take it as 500. This only to create a confusion is given. So first option is given 500. Directly they are selected 500. When load intensity become 10 times, RA is also become 10 times, in which case now? Cantilever beam. Suppose by chance is a cantilever beam. Then in that case, vertical reaction equal to total load. When the load intensity increase by 10 times, reaction also increase by 10 times. But that is valid about when a cantilever beam. Cantilever beam case now. But it is not a cantilever beam now. It is about a statically indeterminate. But this is only to so many times I mentioned now. They are giving us some extra data. That is not required now. We need not use each and every data. Your university examination, they will give the insufficient data and assume suitable data. But GATE and ESC, they will give each and every data. Sometimes they are going to give some extra data. That extra data only need not be used now. That is only to create a confusion. Most of the, around 10% of the students who don't have the basics now. Load intensity is what? 10, RA is 50. Load intensity increased by 10 times, RA is 50. So RA is going to be 500 will be there now. First option is 500. Directly they will select it now. That is valid by chance. This beam is about now cantilever beam. That is when the deflection is going to be less than or equal to 6 mm. Now repeat the same question. Repeat the same question when load intensity is 50. When load intensity 50, what happens now? When load intensity 50, this will become how much is now? When load intensity 50, I'm modifying the question now. When load intensity 50, so what about this value now? It is a 5 mm. Is a 5 mm, means your assumption is correct. Your assumption is correct now. Assumption is correct. That is RB 0. Then directly what the RA now? RA equal to 250. That the beam is about a statically determined beam. That is a cantilever beam. Assumption is correct. Cantilever beam. They were directly RA is equal to what now? In cantilever beam, vertical reaction total load. What the total load now? 250. So RA will be 250. Then what about the moment reaction now? Net moment. What the net moment now? 215 this now. 625 kilonewton meters. In this case, now RA is what increased by 5 times because of what is the cantilever beam. Similar question may be possible in the first chapter like this now. This question I not done your batch. Now you can try the same question like this now. So this type of question once again is possible in the first chapter. This I not discussed. So there is a gap is there between the bar and the support. There is a gap is there. Now is the statically determinate or indeterminate? We cannot tell it now. What do you have to do it now? If the change in length of the bar is less than 1 mm, less than or equal to 1 mm. If this bar is elongated by only 0.5 mm, that much of change in length is permitted, then RD is 0. But if change in length of the bar is, suppose change in length of the bar is 4 mm, but how much is permitted? Only 1 mm is permitted. But the change in length is depend upon the water reactions. So same concept you have to do it now. Same concept. This you can complete it now. First what do you do it now? Assume the RD is 0. Means what the assumption I am making now? Change in length of the bar is less than or equal to 1 mm. Change in length of the bar is equal to less than or equal to 1 mm. Then RD is 0. When RD is 0, directly what the RA value now? P. When RD is 0, directly what the RA value? P. So it is taken as the 2 bars. AB plus BC. But what the load in BC is 0. What the load in BC is 0. So directly what the change in length of the bar? When RD is 0, what the load in BC is 0. Directly load in AB is what? A P. P value is given now. So now you can find out the change in length of the bar. Change in length of AB plus change in length of BC. Change in length of BC is 0 because of RD is 0. So now what the change in length of AB? PL by AE. What the P value? Now 30,000. Length is how much? Now 1 meter. Area is given. Young's model is given. Check it. You are going to get 1.5 mm now. That's why I checked it now. 1.5 mm means our assumption is incorrect now. Assumption is incorrect. Out of that 1.5, how much is permitted now? 1 mm is permitted. 0.5 mm should be restricted now. Then what do you have to do it now? First assume the RD is 0. Then RA equal to P. RA equal to P. So you can find out the change in length of the bar. Change in length of AB plus change in length of BC. But change in length of BC is 0 because of there is no load in BC portion. Want to get an axial load in BC, what? There should be some load at C. There is no load. So directly change in length of the bar equal to change in length of AB. That is PL by AE. 30,000. Length is 1 meter. Area, now check it, 1.5 mm you are getting. But how much is there now? 1 mm is there. So assumption is incorrect. Assumption is incorrect now. Suppose I have given this a 20. In place of 30, if I taken what now? 20. Then this is going to be what? 0.75. If I am getting 20, the change in length of the bar is 0.75 mm. Then it is about assumption is correct now. Then RD is 0. So now, since in our case I am getting more than the gap now, then RD is non-zero. So keep the RD 0. Then it is statically indeterminate. RA will be there and RD will be there. Then how to find out about the compatibility equation now? Change in length of AB plus change in length of BC equated to gap. Change in length of AB plus change in length of BC should be equated to gap. Then you can find out the reactions, you can calculate. The same concept should be used it now. But this should be treated as how many bars? 2 bars should be considered, AB and BC. So this question you can complete it now, same concept now. So for statically determinate bar and indeterminate bar, sir, we cannot decide it. What the answer now? Sir, the change in length of the bar is more than 1 mm. It is a statically indeterminate. If change in length is less than or equal to 1 mm, it is a statically determinate. Then in that case, so what the same procedure now? Assume the first change in length of the bar is less than or equal to gap 1 mm. RD is 0. Then directly RA equal to P. So change in length of AB plus change in length of BC should be calculated now. If I am getting less than or equal to 1 mm, our assumption is correct. But in our calculations, you are going to get, that's why given the data, I checked it now. Check it, you are going to get the 1.5 mm. So assumption is incorrect. Then RD is non-zero. RA is non-zero, RD is statically indeterminate. Then how to find out a compatibility equation? Change in length of AB plus change in length of BC should be equal to the gap. What the gap value now? 1 mm. Gap is going to be 1 mm. So what the change in length of AB? What the load in AB? RA. What the load in BC? Minus RD. Here RA, RD. Because load is acting towards right side. RA towards left, RD is towards left. So load in AB is RA tensile. What the load in BC? Minus RD. Otherwise RA minus P. By using the shortcut method now. Here load is RA. What the load in this now? RA minus P. So find out the change in length of AB by taking load is equal to RA. Change in length of BC, RA minus P, equated to 1 mm, equated to 1 mm. Then you can find out the RA value. Once you know the RA, you can get the RD. But here we cannot do the shortcut method. Sorry, the prismatic and same material. The prismatic and same material can either. The shortcut method is valid. What the condition now? AE should be same. Other one is what? The gap is 0. But here gap is not 0 now. So here shortcut method is not valid. Some students are in the shortcut method. So whenever you want to use the shortcut method, first of all, it should be what? Fixed at both the ends. But it's not fixed at both the ends. Fixed at both the ends means it's a statically indeterminate. But it's not fixed at both the ends. Some amount of deformation is permitted. So we cannot use the shortcut method even though AE is same. So when you want to use that shortcut method, what the first condition now? Bar should be fixed at both the ends and it should be a prismatic and made of same material. So this question is going to be possible. Complete this question now. So this is a compatibility equation. Some friends are giving the answer RA50, RB20. So check it. $1250 RA is equal to plus check this value now. You should get this now. RA I am getting 14 kilonewtons I am getting now. Check it now. RA I am getting 14 kilonewtons. What the load on the first bar? RA. What the length of the first bar? 1 meter. That's the 1000. 1 meter. AE. What the load in the second bar? RA minus 30. Everybody is going to put the 30 only, but you have to convert into newtons. 30,000 you have to take it. Now 30,000 you have to take it. And check it whether length of the second bar is 250 or not. Length of the second bar is 250. AE equal to 0.5. Sir, 1 mm is there. Sorry, this is 1 mm is given. Sorry. So this is 1 mm. So slight changes will be there. So RA will be okay, that only identified 1 mm should be there. $22 kilonewtons you are getting now. Most of them are going to put this at 30 only. You have to convert into kilonewton. Newtons, you have to convert it now. So maximum stress will be 22,000 upon area. So it will be 220 megapascal tensile. Will get it now. $220 megapascals. Check it whether I have given this 250 or not. But the length of AB 1000 is given 1 meter. Check it what the length of the bar. First bar is what? The 1000. Second bar is what now? 0.25 meter. That's the 250. I done the calculation for this now. So for this question, I done it now. So these are the answer for this question. Now check it. I have given the values by using this data. Area taken as how much now? Area is given as 100 mm square. So you can complete it. अभी एक्सप्लेन किया थे संजीव गुप्ता जी, एक बार देख लीजिए. अभी क्वेश्चन किया था ना प्रॉपर कैंटिलीवर बीम का. यूज एनी मेथड, यू शुड गेट द सेम आंसर. Equation is same, but check my calculation. Mostly it should be correct. Anybody vote now? Got the same values or different values now? Only most of the student mistake is they are going to put simply 30. They are going to put 30. Then they are going to get the incorrect answer. They are going to get it now. Initially, somebody are given the answers now, but now nobody is given the answer now. 50, 20, they are all given now. I am not getting any confirmation whether both these values are correct or incorrect now. Okay. So we'll do one more question. This question I am doing for almost last 25 years. I am doing this question now, every batch. But never this was a question is there, but suddenly 3 years back, same question was given in the GATE exam now. On that day, every student was clearly about, sir, whatever you have done in the class, the same question was repeated now. Okay, correct. All my values are correct. Now repeat the same question by taking RA equal to 20. Sir, not RA, this load is 20, take it now. If you take the 20, how much you are getting now? If you take this load 20, initially if the load is 20, or suppose you take the 10 now, in place of 10, if you take the 10, this will be what now? 10 kilonewtons, then you are going to get 0.5 mm, you are going to get it. Try the same question by taking this load as 10 kilonewtons. If you take this load as a 10 kilonewton, then this becomes a statically determinate bar. If this load in place of 30, if it is given 10 kilonewtons, change in length of AB will be less than 1 mm. So the statically determinate bar, at that time RD will be 0. Repeat the same question by taking the P value as 10 kilonewtons. In place of 30, take it as a okay. So those who want to try it, take the same question, taking the P value as 10 kilonewton. At that time, the bar will become as a statically determinate bar. Then directly RD 0. Then you don't need all this calculation, RD 0. Then directly RA will be 10 kilonewtons. If this load is 10, the change in length of the bar, you are going to get it less than the gap. No, less than the gap, you are going to get it. Then at that time, the change in length of the bar, you are getting 0.5. It is less than the gap. Then at that time, your assumption is correct. Means RD is 0. When RD is 0, directly RA will be equal to 10. So what the load acting on the bar? No, 10. So directly the maximum stress is 10 kilonewton upon area. 100 mm square, you are going to get it now. Now this question is an important one based upon what now? I already mentioned this question I am repeating every year now, but suddenly it was given 3-4 years back, same question was given in the gate paper now. Determine change in length of the spring. Change in length of the spring. In the workbook, same question is given. Simply support beam is given, but I have done doing with the cantilever beam. So the statically determinate or indeterminate? Indeterminate. Why? In what ways differ from the propped cantilever now? In propped cantilever, deflection is going to be 0. But that was a rigid support. Now with a flexible support, how much deflection is permitted now? Change in length of the spring. Due to this load, if the spring is contracted by 2 mm, spring is contracted by 2 mm, means how much deflection permitted? 2. So here what the compatibility equation now? When the, due to this load, when the beam is deflected downward, so what the action of the beam onto the spring? Downward. Then what the reaction of the spring? Upward. So how many loads are acting on this beam now? One deflection due to W, one deflection due to reaction offered by the spring. So now what you have to do it now? The deflection of the beam due to W and plus deflection of the beam due to reaction of the spring should be equated to spring deflection. Spring deflection or change in length of the spring. Change in length of the spring. The reaction provided by the spring. The reaction provided by the spring for the beam is become as a concentrated point load. But what the action of the beam now? Action and reactions are equal. So what this downward RB? Due to this load, the beam is deflected downward. Then this Blue color RB, the action of the beam onto the spring. That is becoming as a compressive load. So the spring is contracted, change. That's why what is given now? Change in length of the spring. And this support will offer a reaction. Therefore, RC equal to RB. So this RB, action of the beam onto the spring, will become as the axial compressive load. And reaction of the spring will become as the constant point load. That's all. So what the deflection of the beam? The deflection of the beam equal to deflection of the spring. Deflection of the beam equal to deflection of the spring. Deflection of the spring equal to deflection of the spring or change in length of the spring. Change in length of the spring. But how many deflections here? Not superposition. One deflection due to W, one deflection due to RB. The contraction, the compressive load. Contraction means what you have to take it now? Minus RB by K. RB by K. If a bar is given, what a PL by AE. But here K stiffness is given now. RB by K minus so what the YB1 downward deflection. Superposition RB L cube upon 3 EI. Some textbook they are taking the plus. If they are taking the plus, mean what you have to take it now? Mean they are taking the downward is taking a positive means. So this should be taken as a positive. Deflection of the beam should be positive. This should be negative now. So now simplify, you'll get the RB value now. If you are taking to the plus, some solution they are taking to the plus, means downward they are taking a positive. Then this should be a positive, then upward should be a negative. As per our case, downward is negative, upward is going to be positive. This question. So this is the one method. Sometimes numerical value is also going to be given now. In the same question, in the a simply support beam supported by spring at the mid span. Then at that time, what change you are going to get it now? Constant is 48. Then equation will be the same thing. KWL cube upon 48A plus KL cube you are going to get it. So what the another method you can do it now? stiffness combination, you can use it now. Stiffness. So this beam and the spring are series or parallel? This beam and spring are what? The series are parallel. When the deflections are same means a parallel. So beam and spring are in parallel. In the parallel connection, what the stiffness now? In the parallel connection, what the stiffness? Equivalent stiffness is equal to, in parallel connection, stiffness of the beam plus stiffness of the spring. Because of both beam and spring are in what? A parallel. Spring and beam are in parallel. In series case, what happens now? 1 by k equal to 1 by k1 plus 1 by k2. Here both the deflections are what? Equal. In a parallel case, what you have studied, now deflections are equal and like. So deflection of the beam equal to deflection of the spring mean what? Both are going to be parallel. So in the parallel connection, equivalent stiffness given by summation now. So what the stiffness of the beam? When a cantilever beam subjected to point load, what the stiffness here written now? C2 EI upon L cube. And what the stiffness of the spring is given K. What the C2 value for a cantilever beam subjected to point load? 3. What the C2 value for cantilever beam subjected to point load? 3. So what the equivalent stiffness now? Then deflection of the beam is nothing but about the deflection of the spring. Both are same. How to find out now? How to find out the deflection? W by K, equivalent stiffness. W by K. What the K equivalent? Check it now, same. Suppose bicharge in series. Series means what? The deformations are going to be cumulative. Deformations are cumulative means it's the series. Then in that case, what the equivalent stiffness now? 1 by K equal to 1 by K1 plus 1 by K2. In series, this is also going to be used in your theory of machines, also going to be used now. This is, you can easily remember it now. It's the reverse of resistances. In the high school level, you are going to study the electrical resistances. What the electrical resistance you have studied now? When the resistance are in series, equivalent resistance equal to R1 plus R2. And when the resistance are parallel, 1 by R is equal to 1 by R1 plus 1 by R2. So this is what now? Simply reverse of the electrical resistances. So the stiffness is going to be what now? Stiffness in series and the stiffness in parallel is what now? Simply reverse of the electrical resistances. In electrical resistance, series is what now? equivalent resistance equal to R1 plus R2. Parallel case what now? 1 by R is equal to 1 by R1 plus 1 by R2. This is a proper understanding, but this will take the less time. Who will identify series and the parallel? Who will identify the series and parallel? Clearly studied. Series means cumulative. Deformations means equal, and parallel means, in series case deformations are cumulative. Parallel case deformations are equal and like. Your deflection of the beam and deflection of the spring are same. So it's parallel. So directly summation will be there now. How to find out the stiffness of the beam? C2. C2 into EI by L cube. What is the C2 value for cantilever beam? 3. And how to get the stiffness now? What the load acting on the structure now? What the load acting on the structure? W. This is what now? This stiffness is what now? This is the stiffness of the beam. This is the stiffness of the spring. So what is this overall now? Equivalent stiffness of the structure. Equivalent stiffness of the structure. Then what the deflection of the structure? Deflection of the structure means load acting on the structure. What the load acting on the structure? W upon what the this is total is called as structure. So what the load acting on the structure? W upon equivalent stiffness of the structure. Equivalent stiffness of the structure. And still you are going to study the springs in series and parallel. Springs are going to be covered in your machine design now. Can you find out the deflection at C? Deflection at C. Once again, use the superposition principle. So far, you have done the questions on cantilever beam. Now, you have to do the questions on Simply support beam, same. Use the superposition. First assume the UDL alone. When UDL alone is the downward deflection, what the deflection now? WL to the power of 4, 5WL to the power of 4 upon 384. What the C2 value now? 384 by. Next assume the W upward. What the W value now? What the deflection due to this now? WL cube by 48A. So deflection at C is equal to YC1 plus YC2. What the YC1? Downward. But what the small w value is given now? Capital W. Upon 384 EI. But L is what the length of the beam now? 2L. 384 EI. Next, assume the point load alone. When the point load alone, what the deflection now? WL cube by upward deflection. What the L value now? 2. WL cube by 48 EI. So YC will be so it will be 24 EI. And what about this deflection now? WL cube upon 6 EI. So deflection at C. For the previous question, most of the textbook, they are doing the first method only. The second method is simple, but a student should be what now? It should identify whether they are series or parallel. Already I studied the series and parallel. Cumulative means is a series. Then the equivalent stiffness is 1 by K equal to 1 by K1 plus 1 by K2. Parallel means deformations are equal and like. In that case, equivalent stiffness equal to simply summation will be there now. Here constant is what the C2 value now 384 upon 5. Here C2 is 48, but the span is given 2L. One is the upward, one is the downward. So whatever all the questions you have done it, these are all what now? Done with the standard formulas. Now we'll do some questions where the loading condition is not same as the conditions given in the tabular form. So far whatever you have done it, these are all what now? Conditions which was given in the tabular form, standard loading conditions. Now we'll do some questions. If the given condition is not the same as the standard condition in the tabular form, how to do the question now? So this is a new concept. Based upon this one, number of questions are going to be there. So far in all the questions, cantilever beam is subjected to point load at the free end. We know the formula for maximum slope and maximum deflection of a cantilever beam when constant point load acting at the free end. But here, this constant point, we know the formula deflection at C when this load is acting at C. That is the tabular form third case, tabular form third now. But here this load is not acting at the C, it is acting at B. means it is not at the free end. Now, by using your standard formulas, can you find out the deflection at B or deflection at C? Both are none of them. We can find out the deflection at B. We know the formula for which case now? For this case, we know the formulas. What the theta B? WL square upon 2 EI. YB. So with these formulas, we can find out the slope and deflection at the point of application of load. We can find out about the slope and deflection at the point of application of load. But this load is acting at what distance from the fixed end? L. With this one, we can find out the point slope and deflection at B, that is at the point of application of load. But here load is acting at what distance from the fixed end? L. Now here we can find out, we can use this formula for what? At B. So with this formulas, we can find out the slope and deflection at B. But here load is acting at what distance from the fixed end? L. Now here at what distance acting now? L by 2. So want to find out the slope and deflection at B. So in this standard formulas, you have to substitute L by 2. Some question directly they will ask the deflection and slope at B. Directly can complete it. So the standard formulas are used to find out the slope and deflection of the cantilever beam at the point of application of load. Here load is acting at a distance of L from the fixed end, but here load is acting at a distance of L by 2 from the fixed end. So directly what the slope and deflection now? What the slope now? WL by 2 whole square upon 2 EI. Deflection will be WL cube upon 3A. But in the question is asking at C. In the question is asking at C. Then how to find out now? Now in this case, slope at C and B are equal because of what? Elastic curve is a straight line here now. Here to here shear force and bend moment are 0. Here to here shear force and bend moment are 0. When shear force or bend moment are 0, elastic curve is a straight line. The slope at C and B are equal. So directly you know the slope at C equal to slope at B. How to find out the slope at B? In this formulas, you have to substitute it L by 2. In this formula, you have to substitute L by 2. But what about the deflection at C and B are different. So here you have to draw the shape of the elastic curve. Can you draw the shape of the elastic curve between A and B? Between A and B, the parabola. So this is a deflection at B. How to find out this deflection? In this formula, you have to put it L by 2. But in the question is asking at C. But between B and C is a straight line because of shear force and bend moment are 0. So what is the shape of the elastic curve? Here to here shape of the elastic curve is about a straight line. The beam will bend in the form of straight line. Here to here parabola. What is this black color line? Elastic curve straight line because of shear force and bend moment are 0. But here the parabola. Here to here shear force is non-zero, bend moment is varying, is a parabola. Now I have to find, so deflection at C will be greater than deflection at B. This is deflection at B. Now what about the slope? Now how to get a slope now? You have to draw a tangent to the elastic curve. Now I'm drawing a tangent now. Now the tangent and elastic curve both will coincide. What is the red color line? Tangent. What the black color line? Is a elastic curve. Both will coincide. The black color line is a elastic curve. Both will coincide. Now what about this value now? Is the slope at B or slope at C? Both are same. Because till B, elastic curve, straight line, elastic curve and tangent are coinciding now. So this will be the what now? Slope at B, slope at C. Till B, tangent and elastic curve will coincide because shear force and bend are 0. That's why slope at C and B are equal. So we know directly slope at C. If you ask slope at C, directly you can find out slope at B and you can put it L by 2. But in the question they will ask YC. Then how to find out the YC? YC will be more than YB. We know expression for YB and theta B. But in the question is asking YC. Then what do you do it now? Construct a triangle here now. Otherwise I will call this a C2 and this a C1. C1. So this YC can be written as what? This is a Y1, this is a Y2. But Y1 equal to YB. Y1 equal to YB. I'm interested in YC. YC equal to Y1 plus Y2. But Y1 equal to YB. Y1 equal to YB. Now I have to get the Y2. How to get the Y2 now from this triangle? This theta B means this angle is also theta B. Theta B. Theta B. So from the triangle B1, C1, C2. From the triangle B1, C1, C2. So tan theta B is equal to C1, C2 upon B1, C1. What the C1, C2? Y2. What the B1, C1? L by 2. L by 2. So from this one, Y2 is equal to theta B into L by 2. Because for smaller angle, tan theta equal to theta. For smaller angles, tan theta equal to theta. Now what should I write on the Y max? Y max means what? A YC is equal to Y1 plus Y2. But what the Y1 value? Now YB. What the Y2? Theta B into L by 2. But what about theta max? Theta max equal to theta C. But theta C equal to theta B. Both are equal. So where the slope is maximum means what now? at both C and B, but deflection is maximum at C. Deflection is maximum at C. So how to remember this conclusion now? How to remember this now? Remember now, whenever load is not acting at the free end, that is, when the load is acting away from the free end, whenever load is, when constant point load or constant moment, when constant point load or a constant moment, if they are not acting at the free end, concentrated point load or a constant moment, or simply I'm calling it the load, whenever load is not acting at the free end, if the load is acting away from the free end, then the deflection at the free end is equal to deflection at the free end, that is YB, deflection at the free end equal to deflection at the point of application of load, that is YB, plus slope at the point of application of load multiplied by distance between the point of application of load and free end. So always in cantilever beam, whenever load is not acting at the free end, whenever load is not acting at the free end, so the deflection at the free end is given by deflection at the point of application of load, that is YB, plus slope at the point of application of load, that is theta B, multiplied by distance between the point of application of load and free end. Distance between the point of application of load and free end. What the distance between the point of application of free end? L by 2. So we know the YB theta B. How to find out YB theta B? By using the standard formula. But slope at the point of application of load and slope at the free end are equal. Slope at the point of application of load and free end are equal. So now only you have to do it what now? First you have to find out the YB. How to find out the YB? By using this now. So by using this one YB and theta B, here load is acting at distance of L, here load is acting at a distance of L by 2. So first you have to find out Y theta B. Theta B is W L by 2 whole square upon 2 EI. So it will be W L square by 8 EI. YB L by 2 whole cube upon 3 EI. So it is W L cube upon 24 EI. Downward. Then finally what now? Maximum slope. Theta is equal to theta B. Y max is equal to YB. What the YB value now? WL cube upon 24 EI. And theta B, WL square upon 8 EI. And what the distance between the point of application of load and free end? L by 2. So it will be, check it, 5WL cube upon 48 EI. WL cube upon 48 EI. So make a correction in the tabular form. One small mistake is done by the student. In the sixth row, sixth row, it made a mistake in the tabular form. Make a small correction now. One of your friend is brought it to my notice. So I also not gone through now. He has done a mistake. Sixth case now. For this case, what he has studied, the maximum slope is ml by 12EI. But student has written as what? A y max is written now. Y max is written as ml square by 12EI. Y max is written as ml square by 12EI. So make that correction now. Y max is 0 here now. Here, this is what now? This should be theta at C. So make a correction there now. Y max is, keep it a dash. Keep the y max a dash. Under theta max, write down ml by 12a. Under theta max, you write down as ml by 2a. And C2 is also made mistake now. You make the correction for this case now in the tabular form. C1 is 12. C2 keep it as a dash. Under theta max, you write down ml by 12EI. Y max, you keep it as what? A dash. So this is a small mistake in the tabular form. I not checked it now. He has made a mistake. So in the tabular form, you make this correction now. He has written this 12 under C2 is written now. 12 is written under C2. But C1 is 12. C2 is dash. We don't know. That is not required. I not given now. And theta max is kept it as what? A dash. Theta max is ml by 12EI. And y max is what? A keep it as a dash. But in the tabular form, it is written by the student is what? This is one of your friend. ml square by 12EI is written. Not the deflection slope. Make a correction now. So they make the correction as per this table now. So thank you, Mr. Suprit Kumar. So bringing me this small modification in this now. Maybe due to I not checked it. I hope I thought that he has written correctly. He has written correctly, but he has made a mistake. Maybe some mistake is there now. Make a correction. Once I am informing, in the tabular form sixth case, in the sixth case, make the C1 as 12, C2 as a dash. And y, theta max is ml by 12EI. And y max is dash, y max is dash. But he has written C2 is 12, C1 is kept as dash. And theta max is kept as a dash. And yesterday I have already written in the class now. Yesterday I have written in the class. So always whatever written in the class is correct. But in the tabular form, he has made a mistake. Now, so what the conclusion here? Now, this is very important now. When in cantilever beam, whenever the load is not acting at the free end, is acting at the away from the free end. What the conclusion now? Slope at the point of application of load and slope at the free end are equal because of the elastic curve will become a straight line. And next conclusion is deflection at the free end equal to deflection at the point of application of load plus slope at the point of application of load multiply by distance between the point of application of load and free end. So many questions on this now. But some students, they are making a mistake now. This question. This question they are doing like this now. Sir, we want to find out the slope and deflection at C. What you will do it now? You will introduce the two dummy forces. If this question is given like this now, some of the low standard textbook or some of the students is going to use their own conclusion. Self conclusions are always harmful now. If the question is given like this, find out the slope and deflection at C. Find out the slope and deflection at C. What is going to do it now? He will introduce the dummy force. One dummy force downward. Sir, we have to find out the slope and deflection at C. One dummy force downward. One dummy force upward. Then, if you ask slope and deflection at C, this question now. So then you will write down as sir, I can use the now standard formula, sir. Constant point load alone, constant moment alone. Then I will use the standard formula, sir. Deflection is WLQ by 3I and this is ML square by 2EI. ML square by 2EI. It's a blunder. It's a blunder. Sir, you are done like this, I am doing like this, I am not getting some answer. Sir, why? Here to here what now? Due to this load. If I am doing like this, what happens now? C to B shear force is non-zero, bend moment is also non-zero. But actually due to this load now, for the shear force and bend moment is BC portion. Due to this load. When the load is acting now, what the shear force and bend moment BC is 0. But if we introduce like this, means what you are doing now? You are introducing some new bendiment and new shear force now. They are completely incorrect now. Here what a shear force and bendiment are 0. Due to this load, you are going to get a shear force and bendiment on left side or right side now. Left side is possible. Right side there is no shear force and bendiment. But if you introduce like this, what happens now? What the shear force here now? W. And what the bendiment now? WL by 2. So here shear force and bendiment are non-zero. Means you are completely what now? Violating the given condition now. So everywhere don't use the dummy forces now. But when you do the dummy force now, suppose ask the question is like this. In the question is asked what to find out the slope and deflection at D. Then you can use the two dummy forces now. Due to this load, you are going to get a shear force and bendiment are possible. Due to this load, your shear force and bendiment are possible. So if we ask at D, in the class I done like this now. Sir, when you are done like this, why not do it now? Due to this one, you are getting a shear force and bendiment. What the shear force here now? W. And what the bendiment? W into BD. But here the shear force and bendiment are 0. So if we ask shear force and bendiment at, slope and deflection at D, then you can use the two dummy force concept can be used it now. But don't use this here now. Otherwise, you can do like this now. Suppose if the question is given like this, probably in the class I done this question, I done it now. I done this question, two dummy forces now. If you ask about the slope and deflection here now you can enter the two dummy forces. What the shear force here now, W, and bend moment is what, a W into BC. I done like this now. Because of here shear force and bend moment are non-zero. Sir, you have done like this, sir, you have entered the two dummy forces. Then here also I have done like this now. Here to here shear force and bend moment are zero. Now you are creating some new bend moment and no shear force. Completely incorrect now. If you ask at C, then you can enter the two dummy forces now. So in this question, if it is given like this now, find out theta C and yc. Now you can enter the two dummy forces now. Even if you enter the dummy for the loading condition should remain same. Now, so this W2 and this W will form a couple. So it will be equal to how many loads at C now? Is a correct method. Now you can use your superposition principle. Now you can use your superposition principle. If you ask the slope and deflection here now, what the deflection WL cube by 3a? What the deflection due to this now? ML square by 2a. This is correct now. But don't do like this now. Due to this load, what the shear force here now? W. What the bend moment now? W into L by 2. Suppose this distance L by 2. WL by 2. Now you can also see it now, you are getting the same now. Shear force W and bend moment is WL by 2. But here due to this load here shear force and bend moment are 0. But if you introduce like this, what you are getting now? Shear force I am getting what now? W, and bend moment I am getting minus WL by 2. And here to here what? Shear force and bend moment are going to be non-zero, you are getting now. Now can you give the so what the theta C due to W superposition and due to M ML by EI L by 2. Then what the theta C? And what the deflection now? Due to W, what the deflection now? And due to M, what the deflection now? ML square by 2 EI. Five WL3 by 48 EI. 5 WL3 by 48 EI. Previous question, what you had done it now? If the load is acting at C, we have calculated the slope and deflection by using the straight line concept now. Now load is acting at free end. Now you have to find out. In this case, elastic curve is a parabola. Then in that case, you want to find out the slope and deflection at C. You can use the two dummy force concept can be used it now. But when the load is acting at C, don't use the two dummy forces at B. Now for the proper cantilever beam as shown in the figure, determine the in the workbook this is given as about a separate question now. Two separate questions. But if it is going to the reactions correctly, but the slope they are going to make a mistake. Slope they are going to make a mistake. Due to this, what happens? The beam will rotate in which direction? Clockwise. So when the beam is rotated in the clockwise, what the beam is going to do it now? Push this support downward. Then the support will offer a reaction. What about RA? RA and RB should be equal and opposite because sigma V 0. When sigma V 0, what happens now? Reactions are equal and opposite. There is no there is no vertical load. So what the RA value now? Downward. RA and RB are equal, but it is downward. Next. A moment reaction. Moment reaction. But the assumed after calculation, if I am getting a positive, is a correct, otherwise incorrect. Now. Then what do you do it now? Superposition. For the superposition, first you neglect it now. With the deflection 0 at C or B now. Deflection is 0 at B. But do you know deflection at C due to RB or due to M? At deflection, proper candidate, here deflection is 0. So now deflection at B, that is YB1 plus YB2 0. Now do you know the deflection at B due to RB or due to M? Due to RB is known. What the deflection at B due to RB? WL3EI. But due to M, we know deflection at C. I need the deflection at B. If I remove it here now, here to here there is no load, then it is about a straight line. So how to write down the deflection at B due to this M? Deflection at C plus slope at C multiplied by BC. If I am going to remove it from B to C, elastic curve is straight line, 0 shear force and 0 bend moment. So due to this couple, we know the deflection at C. But I need the deflection at B. So how to write down the deflection at B due to this M? Deflection at C plus slope at C multiplied by BC. How to find out this deflection now? RB eight RB L cube upon 3 EI. Those who are thorough directly can do it now. Otherwise, you can split like this now. So here to here shear force and bend moment are 0. Here to here shear force and bend moment are 0. Elastic curve is straight line. So deflection at B is equal to deflection at C plus slope at C multiplied by BC. So now what the shape of the curve between A and C? Is a circular arc. And here to here you are going to get a straight line. How to write down this now? Deflection at C plus slope at C multiplied by BC. Now you can substitute it now. This couple is acting at what distance? L. Case 1, tabular 1. AC. We know the slope and deflection of a cantilever beam when bending couple is acting at a distance of L. Here also acting at what distance? L. So what the YC? ML square by two EI. Deflection is ML square by 2 EI. Slope is ML by EI. This is L. So it will be 3 ml square downward, but what the m value is given a WL, so it will be Now equate the sum of the deflection to 0. You can equate the deflections to 0 now. You'll get the RB. So YB is 0. That is Y1 plus Y2 is 0. What the Y1 value now? Downward. 8 RB L cube upon 3 EI. What about this value now? Upward. Sorry, this is upward is a positive. This is what a negative. Minus so I'm getting RB is upward. Positive means upward. Then RA will be downward. Then how to find out the moment reaction now? Moment reaction will be I'm getting a positive. Positive means assumed direction is correct. Those who want to thorough, you can also complete the SFD BMD also. This you are getting as nine W by 16. ME is what? Is the assumed direction, no? Is it a clockwise, anti-clockwise? Clockwise. Clockwise are taken positive. ME कैसा पॉजिटिव लिया बोले तो क्या करना है मैंने? assumed डायरेक्शन, क्या assumed डायरेक्शन है ये इसको? assumed डायरेक्शन क्लॉकवाइज है, क्लॉकवाइज का पॉजिटिव लिया था. ये भी क्लॉकवाइज है, पॉजिटिव है. ये एंटी क्लॉकवाइज है, नेगेटिव लिया था. पूरा एसएफडी बीएमडी किया था. डिफ्लेक्शन कर रहे हैं आप. अभी भी आपको डाउट आ रहा है क्यों प्लस ले रहे हैं बोल के. Now can you find out theta C? Can you find out theta C? Most of them are going to do it up to this. Now complete the SFD BMD also, those who want to complete it now. Now is asking slope at C. Do you know slope at C due to M, but we know slope due to RB is known at B, but we need here now. Then what do you do it now? Two dummy forces can be used it now. So in the question is asking what the slope at C. So we know slope at C due to M, but we know slope due to this one at B, but I need it here now. Then what do you do it now? Introduce the two dummy forces here now. If you introduce the two dummy force, what you are going to get it now? Otherwise directly can tell it now. What the shear force here now? Those you are having any doubt, you can put it the what now. So it will be equivalent to. So these two will form a couple. So we are getting a one constant point load in the downward direction. And these two will what? No, sorry, 1 minute. Made a mistake. This one and this one will form a couple. These two will form a couple. These two will vote anti-clockwise. So you are getting a one constant point load upward. One couple clockwise, one couple anti-clockwise. This is clockwise. And what the couple due to this now? Anti-clockwise, anti-clockwise. Anti-clockwise. What the distance between this now? L. So total what the net couple now? This is a WL and this is 9 WL by 16. But this is a no. What this value now? So it will be clockwise. Now you can find out the slope now. Superposition. What the slope due to this now? WL square by 2A. And what the slope due to this now? ML by EI. This is what the slope is what? WL square by 2EI. One couple and one constant, one couple and one constant point load. Due to this one, slope is what? WL by, sorry, ML by EI. So finally, what the slope at B? due to this one what anti-clockwise, clockwise. Now this slope is what anti-clockwise positive. WL square by 16 EI. So WL square by 2 EI. But what's the W value? Now 9W by 16. 9W by 16 L square upon 2 EI. Anti-clockwise positive. Now this is a clockwise positive. What the slope due to this now? ML by EI. What the M value now? ML by EI. So 9 WL square by 32 EI. And this is so 5 by 14, 5 by 16 minus what is the meaning of minus? That is clockwise. Clockwise you are taken negative, anti-clockwise positive. 5 WL square by 16 EI. But if you ask slope at B, how to find? Directly can calculate now. Slope at B directly can calculate it. So this is slope at C, sorry, you made a mistake. But if you ask let's slope at B, what the slope due to this now? WL square by 2 EI. And what the slope if I'm going to neglect it? If I'm going to neglect this now, here and here slope is same. So in that case, dummy force concept is not required now. At B, slope is 0, deflection is 0. Deflection is 0, slope is not 0. If you ask slope at B, you can calculate it now. Slope you can calculate directly. We don't need this now. So this question only most of them are going to make a mistake now. If you ask the slope at B, what is the slope due to this now? WL square by 2A. If I am going to neglect it here to here elastic or straight line, the slope at C and B are same. What the slope at C? ML by EI. So here and here slopes are same. We know slope at C due to M. We know slope due to this RB at B. But in the question is asking slope at C. So then we can introduce the two dummy forces now. Due to this one you are going to get a shear force and bending are possible. So you can introduce the two dummy forces. Either upward means upward, downward. Therefore this upward and downward will form a anti-clockwise. 9 WL by 16. Already one couple is clockwise WL. So your net you are getting what? A 7 WL by 16. This is upward. Now this will give a slope in what now? It is the anti-clockwise, positive. and this will give a clockwise. Clockwise a negative. So overall I'm getting a negative means the clockwise. So they will also ask the direction also. They will ask now. They will not put it as in terms of plus or minus. Finally you have to indicate it now. Deflection also we cannot write down plus or minus now. If I am getting a minus means as per our notation downward is a negative, upward is a positive. If I am getting a theta as positive means the anti-clockwise. Theta as negative means a clockwise. I am getting a negative. That's why the clockwise. First question they are going to do it, but second question only most of the students are going to make a mistake. Now somebody can calculate the theta at B. Theta at B is simple. Theta at B is simple. What the theta here now? Due to this one, WL square by 2A. And due to this now, if when only this couple is acting alone, slope at C and B are same. So what the slope at C due to this now? ML by EI. ML by EI. So here also ML by EI. What the slope here now? Due to this one WL square by 2A. But L value is 2L is going to be there now. And what the slope here now? Slope here is what now? Due to this now ML by EI. Therefore here also ML by EI. One is the clockwise, one is the anti-clockwise. The slope at B become as simple now. So there is no need to use the dummy forces now. Dummy force cannot be valid also. We cannot use it now. This question is given in the workbook now. Determine theta C and YC. So this is not a standard condition. We know the formulas when now. When the UDL is acting for the entire length of the beam. But your UDL is acting only half of the beam. Then what do you do it now? If necessary, if possible, convert the given condition into standard condition. That is, whatever the cases given in the tabular form. Then what do you do it now? Here to your elastic curve is a parabola. It is not a straight line. Sir, zero load. When there is no load from free end to certain distance, elastic curve is straight line. Here shear force and bendment are non-zero. So the parabola will be there now. But the shape of the curve here now, parabola. It is also parabola. But they will have the different slopes are going to be there now. So if the given loading condition is not a standard loading condition, so if possible, convert into standard loading condition. So add a one UDL from here to here now. Add a one UDL A to B. Then that will become the total UDL. So we know the formula now. So whatever the UDL added, that has to be subtracted now. Since it is not a standard condition. So for this one, we know the formulas now. For this one, constants are 6 and 8. Now how much UDL added now? AB portion. This distance I am taking as So we added a UDL of how much length now? L by 2 from the fixed end. Now that has to be subtracted now. Whatever the UDL is added, that has to be subtracted. So this portion has to be subtracted. This much of UDL should be subtracted. Do you know the formulas for this case are not known? Here UDL is acting for how much length now? For a length of L from fixed end is acting at a length of L. Now it is acting for a length of L by 2. So in the standard formulas, what do you have to substitute it now? L by 2. But we know slope at B. With the standard formulas here you can find out the slope at B. What is the slope at B? Here UDL is acting for how much length now? L. For how much length acting from the fixed end to free end? Length of L. Then at that time your slope and deflection are WL cube by 6E8 WL to the power of 4 8E8. Here it is acting for a length of L by 2. So with the standard formulas we can find out the slope and deflection at B. Slope and deflection at B. So in the standard formulas I have to substitute L by 2. But in the question asking at C. Now C to B what happens now? C to be the elastic curve is straight line. So slope at B and C are same. But what about the deflection here now? Deflection at C equal to deflection at B plus slope at B multiplied by BC. So for this case, WL to the power of 4 by 8 EI clockwise. Sorry, this is L cube by 6 EI. And deflection is WL to the power of 4 upon 8 EI. Now you can use these formulas here now. Here UDL is acting for a length of L from the fixed end. Here acting for a length of L by 2. So with this one, by using these formulas, we can find out at B. So to get the slope and deflection at B, in this formula you have to substitute the L by 2. But we need at C. Slope at C and B are same because of what? Elastic curve is straight line. Theta C equal to theta B. That is WL cube by But what about the YC2? YC2 is equal to YB2 plus theta B2 and L by 2. Deflection here, now deflection point of application of load, slope multiplied by BC. What the BC distance? L by 2. Now can substitute it here now. YC2. What the YB2? WL to the power of 4 upon 128 EI. But theta WL cube by (48 EI). W L to the power of 4 upon EI. Then theta C is equal to theta C1 minus theta C2. So it will be 7 by 48. It is also clockwise, it is also clockwise. 1 by 6 minus 1 by 48. Similarly, YC. How you are getting the actual condition? Subtracting the second condition from this now. So YC is equal to YC2. Find out this constant now. So this YC1, 1 by 8 minus this constant. Check it, you should get it the 41 by 384. So these are the answers for this question now. Now repeat the same question. Deflection at D. This is generally workbook question, but this year what now? Probably 2021 ISRO paper. The same question is asked, but they ask find out the deflection here now. Determine slope and deflection at D. Slope and deflection at D. Now you can do the dummy force concept now. First convert this into a total load. First convert this into a total load. So what the next method you have to use? Two dummy force should be introduced. Two dummy forces. One dummy force downward, one dummy force upward. So that also you can skip it now. Directly what now? What the shear force it is. Actually you have to use it to the two dummy force. Directly what the shear force here now? WL. Shear force is WL. And what the bendment now? WL into what is this done? L by 2 plus L by 2. L square. So directly what you can do it here now. If you ask at D, instead of you want to save the two dummy force concept now. Directly find out what the shear force now WL. And what the bendment here now? WL into distance L, WL square clockwise. That's all. Now you can use your standard formulas now. If anybody want to use the dummy forces can be used it now, but it's not required now. If you want to save the time directly you can do it now. Directly what the shear force here now? WL. What the bendment now? WL into L, WL square. If you want to use the dummy force, still you are going to get the same now. This is also not required, unnecessary waste of the time now. You can use it. Check it now. The clockwise. No. So directly what now? Slope at D. Slope at D. This will become the constant at point load. What is the slope here now? WL square by 2A. But what the W value now? Next ML square. M is how much? No, W ML by EI. Five WL square by 8 EI. WL square by 2A and WL square by 2A and ML by EI. This is M and this is W. Same thing you can do the deflection. What the deflection now? WL cube by 3 EI. What the L value now? L by 2. And what the slope now? ML by EI. ML square by 2 EI. ML square by 2 EI. Slope is ML by EI. Deflection is ML square by 2 EI. So the L cube will be there, sorry. L cube. So this question you can try it. This was actual question now. Find out, this was a question actually in the ISRO paper now. Find out the slope at deflection at B. So how many loads will be there now? What this total load now? What the total load now? W by 2. Total load is the W by 2. So here how many loads you are going to get it now? Same concept you can, is only extra load is going to be there now. So what this total load now? W by 2. So here you are going to get a shear force W by 2 means W by 2 and couple it anti-clockwise. Convert this into a total load. Total load is a point load. Then into the two dummy forces here now. So if you enter the dummy force, you are going to get finally one W by 2 upward and one couple. So what the net load you are getting here now? One W by 2 downward and a couple anti-clockwise. What is this total load? The W by 2 upward. So it is equal to here one constant point load upward. So already W is there, here W by 2 upward. Net load is a W by 2. And this total load is W by 2. What is this distance? L by 4. Therefore the WL by 8. This is L by 4. WL by 8 anti-clockwise. So you are getting a one constant point load and one couple but opposite direction. One is a clockwise, one is a anti-clockwise. So with this last question we are going to do it, then we are going for the another method. So this question, this last question, a cantilever beam with a UVL having an intensity of W at the free end. In the tabular form, I have given a cantilever beam UVL. but whose intensity at the fixed end is there, but here intensity at the free end. When this intensity at the fixed end, the constants are 24 and 30. Morning I have given it now UVL, but their intensity at the fixed end, but here intensity at the free end. So it is not a standard condition. Then once again, what do you do it now? If possible, convert to known conditions. Add a one triangle. If you add a one triangle, it will become as a rectangle. Rectangle means UDL. So whatever the triangle is added, that has to be subtracted now. So once again, this is not a given condition, not a standard. So if possible, convert into a standard condition. Add a one UDL. Now this will become as a rectangle. Rectangle means UDL. Now which UVL added now? Red color one. So that has to be subtracted now. Since the given condition is not a standard condition. For this case, you know the constant 6 and 8. Now you can subtract this now. For this case, we know the formulas. In one of the GATE paper, maybe 4 years back, directly this question is asked now. What is the maximum deflection? Who remember directly answer is what? W L to the power of 4 upon 38. But those who are unable to recollect it, they use the Macaulay's method. Somebody use the Castiglione theorem, double integration method. They have wasted the 10 minutes time. But those who are remember directly, the answer is what? W L to the power of 4 upon 38. MCQ question is there now. So here constants are 6 and 8. Here, what the constant for this case now? C1 and C2 are 6 and 8. Here, so theta B. One by 6 minus 1 by 24. Next, yb is equal to yb1 minus yb2. So this is 8ei. WL cube by 8ei, other one is 11 by 120 WL to the power of 4, 120 ei. If anybody want to try any other method, you do it now. Answer should remain same. Right, and the next one is the Castigliano's theorem. Castigliano's theorem. So already mentioned, this theorem is going to be compulsory in objective examination. Unsymmetric loading conditions. for all simply support beam unsymmetric loading conditions, wherever the point of zero slope is unknown, wherever the point of zero slope is unknown. Actually, you have to go for the Michaelis method now. But for objective examination, this becomes simple now. So for all unsymmetric loading questions of simply supported beam, directly can use this method. So for this method, what the requirement already when you are discussing the first step is what you have to find out the strain energy due to bendiment. For the strain energy due to bendiment, integration between A and B, mxx whole square dx by 2 ei, mxx whole square dx by 2 ei. Then we want to get the slope. That strain energy should be differentiated with respect to slope, with respect to constant moment at that cross section. That is what a theta b equal to dou u by dou m. M is the what now? Concentrated moment. And deflection is going to be given by y is equal to dou u by dou w. Let use the already completed the strain energy concept, you have done it now. Strain energy of the beam due to bendiment. mxx whole square dx by 2 ei. So you already done the questions on this now. So once you know strain energy, in the double integration method, what the first step now? You have to write down the bendiment equation and you have to substitute in the differential equation, then you have to do the integrations, you have to find out the C1 and C2 by using the boundary conditions. But here the first step is to what now? Write down the bendiment equation, substitute it in this one, find out the strain energy. So once you know the strain energy, then as per this theorem, if you want to get the slope at A means what? A cross section now. Then this strain energy should be partial differentiated with respect to what now? Constant moment acting at that cross section. Constant moment acting at this cross section. Similarly, deflection. Deflection is given by partial differentiation of the strain energy with respect to concentrated point load acting at that cross section. So where theta A and MA and WA are the concentrated moment. What is the other name now? Bending couple. Concentrated moment and concentrated point load. Acting at cross section. Now this is what the tabular form first case. Cantilever beam pure bending. You directly know the strain energy by using your second method. Three methods you have studied now. So direct your integration required or not required, the pure bending. So directly what the strain energy. Strain energy is ml square by m square l by m square l by 2 ei. Pure bending case. Pure bending case. Next, how to find out the slope now? ml by ei. So to determine the slope, this method the best method now. But this method also some drawbacks are going to be there now. First drawback is what now? Strain energy is always a positive value. So always this method will give the only magnitude. It will not give the direction. Even if I change this direction clockwise, even if I change this clockwise, I'm going to get the strain energy same. So always what, whether this m is clockwise, anti-clockwise, you are going to get the same value. So what the first drawback of this method now? This method will not give the directions. Downward deflection or upward deflection, always it will give the positive deflection only. Whether load is acting downward or upward. And always it is going to give the positive slope only. Whether couple is clockwise, anti-clockwise. What the first drawback now? This method will give only magnitude of the slope and deflection. Magnitude of slope and deflection. It will not give the direction. Sir, then how to decide it now? This is anti-clockwise, clockwise now. You have to decide the direction based upon this load now. This load is the anti-clockwise. So first drawback is what? This method will give the slope and deflection magnitude only. It will not give the direction. Why means always the strain energy the positive value. So always here you are going to get a slope and deflection is positive. Positive means they are not what the direction. It is giving only magnitude. Then how to decide the direction now based upon this load now? Next. Sir, if multiple loads are acting, this theorem is not valid when multiple loads are acting. This theorem is not valid when multiple loads are acting. Sorry. This theorem is not valid when the loads are acting at multiple cross sections. This theorem is not valid when the loads are acting at multiple cross section. This theorem is valid when the loads are acting at only one cross section. At one cross section. Suppose here one more couple is there. This theorem is not valid now. So this theorem is what now? First drawback is what now? It will give only magnitude. It will not give the direction of the slope and deflection. And second drawback is what now? This theorem is valid, not valid. This theorem is not valid when the loads are acting at multiple cross section. Multiple cross section. Means the load should act at only one cross section. Since the load is acting at only one cross section, you can easily decide the direction of the elastic curve. Since the loads are acting at only one cross section, you can easily decide the direction of the elastic curve. Since the anti-clockwise means beam will rotate anti-clock, then theta is going to be anti-clockwise. Next. Now if you want to get this theorem becomes simple for slope or deflection calculation. Examination point of view, objective examination point of view. Shall I use this theorem for slope or deflection? If concentrated moment is given, this theorem is become simple for slope. Similarly, if concentrated point load is given, this theorem is becomes for deflection calculation. So this theorem should be used in the objective examination to slope or deflection. When concentrated moment is given, this theorem should be used to determine the slope. And if a concentrated point load is there, then this theorem should be used for the deflection. Now if you ask to find out the deflection, Can you find out the deflection here now? Your deflection will also be there now. When a beam is rotated, the deflection will be there. But you want to find out the deflection as per this method, what is required now? You want to find out the deflection at B. There should be a constant point load is required. But there is no constant point load. There is no constant point load. Then how to find out the deflection here now? Introduce a dummy force, dummy constant point load. Introduce a dummy constant point load. In which direction? Upward or downward now? To get a deflection here, what is required now? There should be a constant point load is required. But there is no constant point load here now. Then what do you do it now? Introduce a dummy constant point load. Such that in which direction? Upward or downward now? Already this giving a bendment in which direction? Anti-clockwise. So introduce the constant point load such that it is also going to give the bendment in the same direction. Then it should be upward. So to determine the deflection here now, what do you do it now? Introduce a dummy constant point load at B upward. So after introduce the dummy constant point load, find out the strain energy. And that strain energy should be partial differentiated with respect to that dummy constant point load. After into the dummy constant point load, write down the bendment equation, find out the strain energy, and that strain energy should be partial differentiated with respect to dummy constant point load. Then after doing the partial differentiation, make the dummy load is 0. Then you are going to get the deflection. That's why what I mentioned, this method has become simple for slope or deflection now. Now for this example, this theorem has become for simple for slope. Deflection you can do it, but it will take some time. That's why what I mentioned now, this theorem should be used in the objective examination. This theorem should be used for in the objective exam. What the criteria, not the answer of the criterion, both are required now. Correct answer and right time. Correct answer is required within a less time. So this theorem will become the simple for the slope calculation when constant moment is acting. Similarly, when a constant point load is applied, this theorem is become simple for the deflection. But if a constant moment is given, find out the deflection. You can do it, but it will take some time. Similarly, when a constant point load is there, so this theorem becomes simple for the deflection. But when you want to find out the slope, you have to introduce the dummy constant moment. Then it will take some time now. So now to determine the deflection, introduce dummy concentrated point load. Point load W at B as shown in figure. As shown in figure. Shall I introduce upward or downward? Upward, because already it's giving an anti-clockwise now. So put it by dotted line. What's the meaning of dotted? No, it is a dummy load. It is not the actual load. Then what's the next step now? Strain energy should be calculated. Now you cannot use the superposition. So write down the bendment equation. What's the next step now? Strain energy should be calculated. You cannot use the superposition by now. Two bendment, one is varying, one is constant. So now write down the bendment equation. M plus Wx. One bendment is varying, one is constant. Then you cannot use the superposition for strain energy. Then what the strain energy now? Integration. What the limits now? 0 to L. Suppose EA is not constant, you can also vote now. So this theorem vote now can be used for what? When EA is constant and EA is varying. But in this case, I have taken a EA is constant. Suppose by chance EA is not constant. If a tapered beam is given now, if a tapered cantilever beam is given, in that case, what? The moment of inertia is varying. Then you cannot take the moment of inertia outside now. So this method can be valid what? When EA is constant or EA is varying. Both the cases valid now. But whatever you have studied, all the standard equation are valid. All the standard equations are valid when EA is constant. But this method can be what? Valid when the EA is constant or EA is varying. Both you can do it now. So in our case, EA is constant. Then I can take out the first expand the term now. Now this is a strain energy due to what now? This is a strain energy due to this couple, and this is a strain energy due to the point load. But if I do the superposition, you'll get only up to this now. But now because of this A plus 2AB term, you are getting a one more strain energy term will be there now. Already you have studied same now. So this strain energy is due to bending couple. This is due to constant. Now we are getting a one extra term. That's why what you mentioned, superposition is not valid. So this is strain energy in presence of what now? The dummy constant point load. Now how to get a deflection now? Deflection at B. So what the partial definition is 0. This is what now? First term is 0. WL cube by 3 EI. And this term is what now? ML square by 2 EI. So this is a deflection when both these loads are acting alone. Suppose both these loads are acting simultaneously, this is a deflection. Yesterday I done the same now. If both the loads are acting, what the deflection? WL square, WL cube by 3 EI. Other one is what? ML square by 2 EI. But in our case, W is not the actual load. It's the dummy load. So to get an actual deflection, what do you have to do it now? Substitute W is equal to 0. If I substitute W is equal to 0, ML square by 2A, I am getting only positive value. But how to decide is about upward or downward now? The couple is what? Anti-clockwise, what is rotating anti-clockwise, therefore it should be upward deflection. So you can see in a slope we are getting easily, but deflection you can do it. Deflection at this cross section you can do it, but it will take some time. That's why what I mentioned now, this method should be adapted or should be used in the objective examination for slope or deflection. If a constant point load is given, if a constant point load is there, use it for deflection. If a constant moment is there, use it for the slope now. Generally, objective examination only one value is asked now. Suppose if this question is asked now, they will ask only slope will be asked now. But what the advantage of this now? What the advantage of this theorem now? It is valid for both symmetric loading, unsymmetric loading, as well as what now? Even when EA is not constant, also valid now. Even when EA is also not constant, is also valid now. Is symmetric or unsymmetric loading is unsymmetric loading. Here you cannot use the double integration method now because of location of zero slope is unknown. Location of zero slope is unknown. So we cannot use here double integration method, but here you can use it now. But the Castiglione theorem becomes simple for which calculation now? Here which load is acting now? W is acting. So the Castiglione theorem becomes simple for deflection or slope now. Deflection where now? At B only. Castiglione theorem becomes simple for deflection where constant point load is acting. Where the constant point load is acting now? B. So here you can easily find out the deflection. This is the last case in the tabular form. Yesterday given the tabular form now. 11th case now. You can see the tabular form. So here we cannot use here double integration method. You can, most of the students are going to use those who are not thorough with the Castiglione, they will use the Michaelis method, but the time taking now. There also you have to find out the C1 and C2 now. You can use the Michaelis method. Double integration method is not valid because the point of zero slope is unknown. So you have to go for the Michaelis method. Michaelis method we can use, but it will take some time now. But if you ask both slope and deflection, you have to go for the Michaelis method now. If you ask only deflection, this method is better now. So in the question, obviously they will ask what now? Find out the deflection at B. Only they will ask this type of objective examination. All unsymmetric loading questions, they will ask either slope or deflection. If a constant point load is given, they will ask the deflection. If a constant moment is given, they will ask the deflection. Constant moment means they will ask the slope now. So what should be the first step now? Find out the strain energy. What the unsymmetric loading? What this reaction now? This total length is L. And this reaction is WA by L. So strain energy of AB plus BC. Take a section. So what the bendment here now? W by L into X. What the limits now? 0 to A. And here what the bendment now? W by A by L into X. But what the limits now? 0 to B. So limits are for AB, 0 to A. What the bendment equation now? WBX upon L. 2 EI. And for BC portion, what the limits now? 0 to B. So you can complete this integration now. but a plus b equal to L, a plus b equal to L. Therefore, this will become as 6 EIL. So deflection at B. Deflection downward or upward? Downward. Load is acting downward. But if you ask the slope, it will take some time now. Objective examination, they will ask only deflection. In a conventional paper, they will ask both slope and deflection. Then at that time, you have to go for the Michaelis method. But I am teaching only for this chapter, only for objective point of view. Only objective point of view. Some batches I discuss even the Michaelis method now. But no student has used that method now. Sir, we are preparing for only GATE and ESC only, ESC prelims only. Previous question becomes simple. What of? For previous question, Castiglione theorem becomes simple for slope. And here Castiglione theorem becomes simple for deflection. All these questions, whatever I am taking, they're all unsymmetric loading questions. This is only what a GATE paper question, probably question number 5. Question number 5 is going to be this now. Yesterday I have explained this now. For the slope we got it now. ML by 12 EI. But for this case, slope is what now? Span is 2L. So ML by 6 EI. But how we got it means what? For this question now. So Castiglione is a symmetric or unsymmetric loading? Unsymmetric loading. Unsymmetric loading. Now here Castiglione theorem better for what now? Slope at B. In the question is asked slope at B by using the, in the question actual exam is asked what now? Slope at B by using the Michaelis method now. But in the objective examination, nobody is going to check it now. Which method you are using now? In the actual workbook question, the GATE question, they ask by using the Michaelis method now. But who is going to check it? Which method you are used it now? So you can directly use a Castiglione theorem can be used it now. Castiglione theorem can be used it now. So what are the reactions now? M by 2L. Now strain energy of AB and BC are equal or unequal now. If the strain energy of the two members should be same. If the strain energy of the two members should be same, what the first condition now? Limit should be same. Bendment equation should be same. Limits are same. Limits are same. Equation also same now. But one is a positive, one is a negative. That will not make any difference. Here sagging is the hogging. But strain energy calculation plus or minus will not make any difference now. So whenever the strain energy of the two members should be same, mean what now? Limit should be same, load equation should be same, and corresponding rigidity should be same. But here bendment is a positive, here negative. That will not make any difference now. So strain energy of AB and BC are equal. Now check it now. Limits are same. Equation also same. So strain energy of AB plus BC. So it will be 2 times the strain energy of AB. What are the limits now? 0 to L. What is the bend moment equation now? mx by 2L. For all these questions, here then what the slope now? Direction you have to decide it now. It is anti-clockwise, clockwise. Therefore, it is anti-clockwise now. ml by 6 EI. So let me do one more question, then we'll take a break. We'll take one question on overhanging beam. It is a one-sided overhanging beam. So once again, unsymmetric loading. Now Castiglione theorem is better, but which calculation of slope at C? In objective examination, they will ask only at slope at C. Determine slope at C. Now once again, what the reactions now? Sigma V 0, sigma M is non-zero. Reactions are net moment upon the span. What the net moment M? Span is how much? L. Is the anti-clockwise. Therefore, reactions are M by L. When sigma V0, sigma M is non-zero, reactions are equal and opposite, and they are equal to net moment upon the span. What the net moment now? Anti-clockwise. So reaction should give a clockwise direction. So now what the strain energy now? Strain energy of AB plus BC. Now what the BC, bend moment is constant, therefore the pure bending. Here what the bend moment in the BC portion plus M. So pure bending, therefore directly can use the M square L by 2 EI. But here bend moment is varying, then you have to go for the integration. What the limits now? 0 to L. What the bend moment equation now? Mx upon L. EI. For BC portion, what are the limits now? 0 to L by 4. But bend moment is a constant. Either you can go for the integration or directly can use the m square L by 2a, pure bending. Here bend moment is constant. Check it, I am getting constant as 7 by 12. So like this, what all the unsymmetric loading questions you can complete with the your Castigliano's theorem. Here you should know the bend moment equations. Now to write down the bend moment now. 7 by 12 you are going to get it. So what the first drawback of the Castigliano's theorem? Castigliano's theorem is not valid when the loads are acting at multiple cross sections. Means the load should act at only one cross section. Load should act at only one cross section. When the loads are acting at multiple cross section, this theorem is not valid now. Next, this theorem will not give the direction of the slope and deflection. This will not give the direction of slope and deflection. You have to decide, because loads are acting at only one cross section, you can easily decide the directions now. Next, this theorem becomes simple. This theorem becomes simple. Slope at a cross section. When this theorem it becomes for the calculation of slope at a cross section where constant point load is acting. Here constant moment is acting. This theorem is becomes simple for the slope at a cross section where concentrated moment is acting. And this theorem is becomes simple for deflection at a cross section where constant point load is acting. In this question, load is acting at which load is acting now? Load W is acting at B. So this theorem is becomes simple for deflection at B. Here couple is acting. This theorem is becomes simple for what now? Slope at B. And here this couple is acting at C. So this theorem is becomes simple for the slope at C. Seven ml by 12 EI. Okay. So some more examples here are going to take it if EI is not constant. So 1 or 2 examples here are going to take it after the water. For this one already I completed the strain energy calculation here completed. Bend moment you already thorough. Only you have to do the partial differentiations are required. So we'll take a break and we are going to meet exactly at 12:50, 1:50 you are going to meet it. 1:50. So we'll discuss some more examples on the if when EA is not constant. So that questions you are going to discuss after 1 hour break. You are going to discuss it now. So those you don't have any queries, you can log off your system and you can join exactly at 1:50. If you have any queries, please send your queries. So I'm going to If it is a genuine queries, I am going to respond to your queries now.